Hello, everybody. Thanks for being here. Well, let's get started. My name is Jim Manico. We're going to talk about a project that I'm working on with a bunch of other folks. It's another top 10 list. It's the OWASP top 10 proactive web application controls. We're like at beta stage now, and we're getting ready to get an artist and build the final document and get ready for the formal release. I want to let you know where we're at and the purpose of this project and why I think it's important. And we'll talk about some high-level things in secure coding, and we'll drill down deep and do a few low-level things just to make it somewhat technical here. So let's talk about it. My name is Jim Manico. I'm one of the global board members, elected global board members of the foundation of the OWASP Foundation. I work on the OWASP cheat sheet series, the top 10 proactive controls, the OWASP Java encoder, and the HTML sanitizer project, all defensive coding projects of some form. I'm primarily a secure coding author and instructor. I teach developers. I'm passing the 50,000th developer I've sat and taught at one point. It's something that's a lot of passion, a lot of fun to do, and trying my best to make a difference. And I'm insane in that I'm working on well, I'm insane for a lot of reasons, but another reason for my insanity, I'm working on a book with McGraw-Hill on Java security as part of their Java web series. I've never done so much painfully slave labor type work while people are whipping me and being abusive to me for lower than minimum wage, but it's a very rewarding process. Okay, so, and I'm from Kauai, from Hawaii, aloha, and I'm an unofficial resident of Orange County. So I'm in OC quite a lot, because OC is the cooler part of LA, I'm told. Is that right? No. Whoa! The Orange County people keep telling me I'm supposed to say that. All right, moving on. So a warning first. Look, folks, this is an awareness document. There are more than 10 issues in application security. You cannot base a full application security program off a top 10 list. That's quoted by Jerry Hoff's Law out of Computer World, where he was criticizing some of the top 10 lists. Awareness documents are important. I do think this is an important project. There's 20 million developers. Many developers still are learning about secure coding, even in 2014. This is a great place to start. This is not where you end. So this is an intro level talk to some degree. Without further ado, let's get into the OWASP proactive controls and how we message developers initially around secure coding and secure coding awareness. So first of all, you can hack yourself all day. We cannot use assessment techniques to secure our organization. Let me make an even stronger conjecture. If you're not engaging your developers, it's impossible to have a mature application security program. A lot of large to small companies feel they can do things like, well, I'll do static analysis and we'll patch those, or we'll use a firewall and block it, or we'll do things away from the developer to try to prevent security problems, and those methodologies at scale fail, and they fail painfully and brutally. So I'm going to say it again. If you're not engaging your developers in some way, it is impossible to have maturity in the world of application security, and this is probably the biggest culture change in information security since the dawn of this discipline in the 60s and 70s, where it really started. So we're at the cusp of a huge culture change. We have to engage developers. Traditional security skills are no longer effective to deal with this problem. And because of that, we have systemic application security failure across every company and every government on the planet right now. If you're working for a big company and you're thinking of the problem you're facing and the struggles you're having, you are not alone. Everybody who's a peer of yours within the world is facing the same problems. So it is I think a lot more systemic of a problem than statistics and financial reports say from my experience and the number of things that I see that are not reported. All right, let's get to it. Number one, this is also not exciting stuff. One more ado first. This is also not exciting. The work of security is often in the minutia of how to encode properly or how to write this line of code properly. A lot of the high-level talks don't address the problem. Query parameterization, you have to do secure design, because a lot of the things that really help you defend your company get to be minutia and boring. And the things that are exciting that we really want to do, like malware analysis, and I want to go hit that web app, and all the these are fun things. They only do so much to really protect your organization. So we got to engage developers. Enough. All right, come on. Security, architecture, and design. This is a strategic effort. The win you get from this doesn't pop right away. You're not going to see it for a year until you've built the software, you're in production, and you see the statistics of how secure that's been over time. So and it's against human nature to do strategic efforts, especially developers. We want quick wins. We're trained to do quick wins. So very often when you're doing strategic design and thinking ahead, it's counter to software development culture in many organizations. Because our culture is to go faster, be more agile. Forget agile. Agile's too slow. Let's do DevOps. You're writing code, push that live right now. Just go, go, go. And it's like, it's crazy like how little software engineering discipline is following with these methodologies as well to some degree. So strategic effort, whether it's a quick iteration or a month-long cycle, it doesn't matter. We still want to get the business, technical, and security stakeholders together to agree what security requirements are going to be, to begin building like what our software is going to look like, what controls we need and where we need them, and how we can define the security characteristics of their software. Here's one example of the kinds of conversations that I have in design. So we're building a feature. We're building a feature to do account locking. We want to detect brute force attacks. We notice when a certain number of failures to log into a certain account occurs, and one of the choices we have is to lock that account in some way. So the question is, we have to keep track of how many login failures that we have for each individual user. But where do you track that number? Do you track it in the request on the URL? Do you track that in the session? Or do you track that in the database? Where do you track the number of login failures per user? What do you think? Anyone want to counter that, or? Mark, I love you. I feel it like platonically. I'm gonna pick on you. So this is a common incorrect answer. Mark is. I mean this respectfully because I hear this more often than not. I hear that answer. I rarely hear that answer, and you're right. Here's why. And I see a lot, this is a common failure I see as well. If you're tracking the current login failures in session, what tells me in the request which session I'm hitting? A cookie. And as the attacker, how can I make sure that every request to log in is a unique session? I will just drop the cookie from every request, and that session tracking is no longer useful. With respect, you must keep it in a persistent store. In fact, I've even seen the login failure in the URL as URL parameter, which I can just change every time. So unless you're like a developer writing web code every day, this is an esoteric, minutia, meaningless conversation. But to a developer and to secure coding, this means everything. And so these kinds of questions I like to, at least to some degree, I want to have these pop up in design. Because if I talk about it to the developer and say, dude, put it in the database, how much extra effort does it take him to do it? Almost nothing. But if he's already got it in the URL and I have to go back and fix that, the cost to redo that is dramatic. So that conversation saves you about $16,000 in remediation time for that one issue. Now expound that out to about 50 or 60 different issues, you're starting to save there's real measurable savings when you do design properly. And again, the process of secure design, I'm thinking fast, iterative, and if this becomes like a 3-day process, it tends to fail. So the shorter and more concise it is, the better usually. So here's a comment from the field on the whole topic of secure design. This is from Jim Bird, who's begun to help with the project. Jim works on a stock exchange in Canada and has built some of the most high-risk money transfer software that they use up north. So he's saying we also must discuss tiering and trust. We want to decide what's done in the user interface, where do controls go in the web layer, what goes in the business layer, where do we do data layer protection, and he's talking about different trust zones and boundaries. Like if I'm doing input validation at one layer, and I have a sub-layer, some kind of message bus that's only used by this system, do I build controls at every single layer? Now my instinct is yes, you must build controls at every layer, but unfortunately, this is not practical. And so, we do need specific controls at certain layers, but the problem is that if I'm doing pure security and I'm building controls in at every single tier, we run into performance problems, we run into practicality problems, and we just don't have time to do everything. So we often have to take shortcuts for practical reasons. That's the real world. So as much as I like these controls at all layers, breaking up design into different trust boundaries where we depend upon controls in one layer for another is just fundamental to secure coding. So This is some comments I got from the field that I think is practical, reasonable feedback when it comes to that topic. So we're high level. We could talk about this topic alone for days. We're going to move on though. What should fall out of design meetings are clear requirements. Who here is a developer of some kind or works building software? So those of you who just raised your hand, have you ever in your career gotten a requirement from the business that defines what security should look like in your software? No, 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 no. No, absolutely no. I wish it was a yes, but I still see a no. So anyone? So this is a problem. Think of what a developer is. Think of a developer as like a machine. You give them requirements. What are they going to do? They're going to do their best to build those requirements. So one of the major problems that we see in software development is almost nobody. I'm talking some of the most senior teams I've worked with. They don't do requirements for security, and make no mistake, all that security is, they're additional features in software. It's not a completely accurate statement, but it's pretty close. Security, they're just additional features in software. And let me break it down. Number one, we have functional requirements. These are visible features that we can see in software. Forgot password workflow. That's a visible feature that I can spec out, build with a normal developer, and have QA verify if that works to some degree without needing a security professional, because it's visible, it's clickable, I can script the testing. That's a great thing. So there's also, and this is probably what's more difficult to get your hands around, the non-functional requirements. These are invisible quality aspects of software. It's not easily testable by QA staff. This is where we begin to really need different security, professional security assessment. We should also be reviewing some of those as well. And things like query parameterization. I can grab one of the most high-end QA folks there are. They can test the functionality of my application all day with perfection and never test query parameterization, never test if SQL injection exists. That's not functional testing. That's specific to security testing. So I like to break down my requirements into these two buckets and deal with them very differently in my organization. That seems to be a more efficient way to approach the problem. So comments from the field from Jim Bird. We also have to address business logic requirements, which is a much, much more difficult task to spec out and design, because you have all the branches for the business to handle a complex business logic workflow. And what happens if a step fails, or if a step is skipped, or if it's replayed or repeated? These are the things and problems we're looking for. And in Jim's experience, just thinking about errors and edge cases with your developers will close a lot of holes. Now, I wish I could think about something and close a hole. So what he means is, so that's a joke. Thank you for someone almost laughing. But he's right. If we get developers in a room who are intimate with this software and begin just discussing some edge cases with them, they'll get it right away and begin to provide defenses and discuss defenses with us. The thing is, developers are incredibly sharp people. This is complicated software they're working on. If you bring good information to them, they'll often come up with better defenses than a security professional will, in my experience. So a lot of what I learned about secure coding is taking advice from OWASP and from the canon of secure coding knowledge, presenting it to a developer who would say, that's a good idea, but I think we should do it this way. It's better for our business. So I've learned more than teaching, because we get into the real world. There's often different subtle things that a developer will tell us that a security professional will not. Last, privacy requirements. This is fundamental to building software in Europe. It's not that important in the US though. Excuse me. It's really not. Now, I say that partly as a joke. It's also true though. We have no legislation that forces us, for the most part, to care about users' privacy. And if anyone's done business internationally, do you know what the privacy laws are in Germany? It's very different than the US. So I mean this, I'm not trying to get political, I mean this just in practical terms. If you're building software and you have international requirements, your privacy requirements radically change. And if you don't follow them, the punishment in Europe for breaking privacy laws are extreme. Some legislation says your fine is going to be 1% of the gross of your company. That level of extreme. So we'll see how those laws play out in the next year or two. So next, and I think this is we're on number 3, leverage the security features and frameworks of security libraries. Just to mention one, like I focus a lot on the Java ecosystem, and frankly, one of the problems with Java and .NET and PHP and most modern web APIs is they're all role-based access control driven. Is the user an administrator? Let them do this. Is the user a manager? Let them do this. What do you think of role-based access control as a design pattern? Pardon me?
Course.
Course. Who said that? I mean, that was like almost throwing it under the bus. Like, that's like throwing it under the Volkswagen Bug. Can you throw it under like a real bus and drive over it a few times? Let's get more. It's. What's that?
I was going to raise his hand open.
What do you got?
Well, it's just like, you know, a lot of times you like to be able to really fine tune it. And so you just put this person, that person. But then, of course, the real challenge is it gets really complicated to try to do that.
Here's.
What about attribute-based access control?
I'm like a zealot to talk about ABAC. This is a new NIST standard that just came out actually like 2 weeks ago. Or anything basic. Let's get into it. So in the Java ecosystem, in the .NET ecosystem, in the PHP and other ecosystems, even the frameworks that are common, they're all role-based. Role-based is too coarse. Role-based access control will address hierarchical access control problems. You have a manager, you have an administrator, you have a hierarchy of roles and permissions. It solves that problem somewhat well. But what if we're both the same role with different data contextual rules for each of our accounts? Like, should I be able to get a report for someone in your division? Stuff like that. And those data contextual access control checks, role-based access control just does not address them at all. Things like attribute-based access control and standards like YACML do begin to address these things. In the Java ecosystem, and this can be ported to, it's just the idea, not the library that's important, but in the Java ecosystem, Apache Shiro is one of the only projects out there that does attribute-based access control and has done it for quite a few years and does it well. And the thing that psychologically makes it difficult to embrace is there's a lot more setup work and the benefits show up later, and that's usually counterintuitive for developers. Let me give you an example of this though. Do I have a picture of this anywhere in here? I love to go like asynchronous through my slides. So I'm gonna jump ahead and talk about this in the access control section. I'll jump back. So when I look at access control anti-patterns, here's some of the other problems with role-based access control that we see in almost every major framework. People hard code roles in code. Ever do a code? Who has done a code review? Do you ever see in code, if the user is a manager, or if the user is administrator, or if the user is a user? Ever seen code like that? Every time you see it, flag it as an anti-pattern. That's not how you write good access control code, even though we all do it. Those hard-coded role checks in code, you're now hard-coding policy in code. And if I want to change that code and change the policy, I have to write and push new code. This is a major problem with complex software, especially multi-tenant software, which is really common in the world today. The lack of centralized access control, untrusted data driving access control decisions, like role equals user in a cookie, and change that easily. Access control that's open by default. When things fail, it fails open. Lack of addressing horizontal access control. That's the data contextual access control. If you and I are the same role, we still may have different access control rules for certain pieces of data. Access control logic needs to be manually added to every endpoint in code. That's the problem with role-based access control. If I forget to do my role checks in that code, it's open by default. I have to go and hard code role checks in to get my access control. That makes no sense. An access control that's sticky per session, where if the user is already logged in and I change all their permissions, do they have to log off and log back in before that takes effect? Usually it's yes, especially for highly scalable systems. They're tuning it for performance reasons. Or how about access control that requires per user policy with no grouping? These are the problems I see with role-based access control and modern access control implementations. Let's contrast this to activity-based access control and data contextual access control. And yes, I'm stealing your intellectual property, Disney, and I'll remove it if you want.
I'm not sure the problem is necessarily with role-based access control. The problem there is with implementation.
Yeah, you're exactly right. It's not the ANSI standard RBAC that's the problem. It's every single implementation of it I've ever seen. I've never seen role-based access control implemented correctly in a language. Java default access control, struts, Spring, PHP, the Zen framework, Ruby on Rails, they're all role-based in the language, they're all role-based with this kind of anti-pattern list rather than RBAC that does activity-centric checks. It's a real subtle point, but it's a major flaw. So here, let me show you an example of what I mean by role-based versus activity-based. And Okay, so here we have a video game. We have a Star Wars video game. We want to check if a user is allowed to wield a lightsaber, a common event in the game. There might be 5,000 places in this game where the user can choose to wield a lightsaber. So I'll have to do a check to see which roles are allowed to conduct this action. And over time, I have to keep adding more roles. I have a Jedi, the different Luke and his buddies. You got the Padawan, different trainees. You have the Sith, the different Siths. They're a whole different class of characters with different powers. You have exceptions to the rule. Here's General Grievous from the 4th movie. He is not a Jedi. He is not a Sith Lord. He's just a fighter who's a cyborg who was trained by the Sith to conduct a lightsaber battle against Jedis. Sorry. And so these are all different roles, and every time new roles show up, like in one movie, Han Solo wields a lightsaber to open up some container, so we have to give that as an exception, and it will never end. Every time a new class of character comes in, we have to change that code, push new code live in like 5,000 locations. That's a failure. So how we do this correctly, I dare say, is with activity-based access control. I'm no longer checking who the user is or what their role is. I'm checking on what activity they're executing. If the user is permitted to wield a lightsaber, let him do it. I write this code like this once, I'll never change it again. It'll be in a back-end persistent store, some kind of YAML store. And so we can technically call this role-based access control, but because of how bad modern implementations are, we got to rename it. So it's renamed by NIST about 8 days ago, and they call this activity-based access control. Finally, NIST released detailed guidance on moving away from role-based access control. It's really required reading if you're into this. All right, let me move to a new topic here. My asynchronous approach, I apologize. Let's go back a bit. What's that? We'll get to some WoW. We'll get to. You got to talk about WoW. WoW is important. So, in the context of what I'm talking about, we're talking about using security frameworks. I use that as an example to talk about access control and an example of an activity-based framework like Apache Share that handles this. Don't do your own crypto. You will always get it wrong. The best people in the world get applied crypto wrong. We want to use an abstraction like Google Keysar. Google Keysar will give us interoperable encryption storage between Python, C++, and Java with key rotation, all the benefits we need. We'll get to that more in a little bit. We have things like cross-site request forgery defense. Here's an attack against a home router from the outside. And why I bring this up now is because CSRF should be defended at the framework level. This is not something you should be coding. Struts, Spring, Ruby on Rails, the Zen framework, every major framework out there, they have this built in now. Even Spring, which is late to the game, they implemented this a few months ago as well. So if you're defending against CSRF by hand, that's usually because you have an old framework. We can solve this. We can solve this in modern frameworks without a lot of extra work. Another example of a security library that's critical in the Java ecosystem is doing output encoding. Java does not have a library to stop XSS. Even in J2EE, they refuse to because they're like, hey man, that defense is a web domain and core Java is for any domain, so we'll let other people do that. So here's an example of an OWASP library, which I feel is highly production ready for output encoding. I recommend it on a regular basis. We're going to push a new version out in about 2 days. This is an example of a small library which you can use in your own framework to give you security in a fairly standardized way. We also have HTML validation. This is from Mike Samuel at Google. This is another core component that's missing from the Java ecosystem that's fundamental to good security that we have in a well-maintained project written by a pretty deep expert. And as a side note, the way you can best institute this into your organization, this all kind of gets tied together with education. You build your software security framework, you leverage existing secure coding libraries and add in your own custom security libraries for things like authentication. You build your education, not some generic education, but education around how you expect your developers to write secure code specific to your framework. You do your threat modeling around your framework, and it all kind of flows together in a much more efficient manner than more generic approaches to application security. Into identity, category number 4, there's a whole family of things we want to deal with when talking about authentication identity. This one topic alone we can blow out into a week-long conference and not cover the whole topic. I focus on a few simple things while I'm here. I'm going to talk about password storage first. So password storage is probably an area of authentication identity, which I see wrong more often than not. I state with respect. We've seen a large number of high visibility attacks on websites that were specifically trying to steal password storage data, then pop it out to the world. And so what are some really bad ways to store a password? Yeah, what's a little less worse than that?
Database.
What kind of crypto? What's
Unsalted hash.
unsalted hash? How tough would it be for me to crack an unsalted hash less than 8 characters? Google it. Just Google the hash and you'll get an answer out of the Google rainbow tables.
Can do it in less than 8 seconds, or less than 1 second.
What's that?
John the Ripper can do it in less than 1 second if it's in the dictionary.
Even better, you can go get a GPU cracking rig. It's basically a video game machine, slap in a bunch of video games for about $5,000. You can do about 10 billion hash checks per second. Not per day, per second. That's what, so most crackers don't use rainbow tables anymore because they're too slow and they're too big, like 10 terabytes for a reasonable one. Why would you need a rainbow table when you can throw 50 billion hash checks at something per second locally? So that's the more modern way of approaching password cracking. Because of that, we need some pretty rigorous defense when doing good password storage crypto. I'll give you a few suggestions. Number one, don't limit the size or type of the user password. Let them use whatever character they want. We see a lot of people trying to strip out single quotes and certain characters from passwords to prevent other attacks like injection. This is a path doomed to failure. So you don't want to deal with injection protection by limiting characters. You do it by encoding and query parameterization. So we want to make sure that for password storage, first of all, let large passwords with any characters to be allowed, but be careful of systems that allow unlimited size passwords. We saw a denial of service against Django in September of 2003 because they were using PBKDF2 and with a really large work factor and allowed unlimited size passwords. So a 5 megabyte password makes PBKDF2 grind and shuts the system down. So like 100, 150 characters is a good max length. Number two, use Assault. Now, Assault alone is not going to save you, but here's what Assault is all about. When a user first registers, who here knows what Assault is? Who here wants me to skip that part? Let me skip it. So what do we, let me challenge you then. What do we use Assault for? What's the purpose cryptographically for Assault in password storage? Okay, so
Frequency attacks.
what's that?
Frequency attacks.
I'm gonna go one even better. The real purpose of Assault is deduplication. So let me go into the Assault. It's a little different information. So when you have a rainbow table, in the world today, we can get rainbow tables up to about 10, 11 characters. That's over 10 terabytes. Any rainbow table past 10, 11, 12 characters that are complete, they blow out to hundreds of terabytes and they're not practical anymore. And so one thing we can do is when a user first registers for a system, we generate a random salt for that user only and add it to the password before we protect it. That makes the password look like 60 plus characters in length, and rainbow tables do stop working. But they're not even in use by hackers anymore. The other thing Assault protects you from is duplicate password type attacks. And bear with me. Suppose we're using a basic hash to store a password, and you and I have the same password. I'm going to reveal I know your password. I've been checking. I'm going to tell everyone what your password is, because it's the same as mine. Fluffy Bunny 1. Am I right? Am I right? He's like, I'm not going to play your Fluffy Bunny game, Jim. All right. That's fine. So we have the same password. What's our ciphertext going to look like? It'll look the same. When we each have a different random salt, though, and it's different for each user, that just deduplicated our ciphertext, even when we have the same password. Because if I get to your database and you have this deduplication problem, I can get the hash of one password and check the whole list quickly and do that a lot. It's a really easy way for me to hit the system. Salting makes that go away. Is Salt enough for security? We saw no attack on Living Social, but Living Social was hit, 50 million plus passwords stolen. Their password storage was a salted hash. That's it. What do you think? Good or bad?
Same salt.
No, different salt for every user. Here's why it's a bad idea. If they were using a hash like SHA and they were using a salt, this is a horrifically bad idea. How many hash checks can I do for $5,000? 50 billion per second. So your salted hash, what do? For each user, user number one, grab the salt, attempt like 30,000 of the world's most commonly used passwords and see if I get a match. and I can hit like 15 to 20,000 users per second with good password lists. So that's the problem there. Pardon me? Yeah, I'll just write a little script. And I get your database, I get your salt, and the hashes for every user. I grab the salt, I try a million of the world's most commonly used passwords one at a time, look for a match. And it's easy code to write, that's what crackers actually do, and GPU cracking defeats that. So I'm gonna make 2 recommendations for password storage. If you're like dealing with hundreds of thousands of concurrent users like a Twitter or a Google or even a top tier bank, I'm going to recommend something called an HMAC, an authenticated hashing algorithm and isolation of that process. So an HMAC is a hash that requires a private key. It takes the private key and adds the text and then hashes that twice. So if that private key is controlled properly, even when someone steals your hash, rainbow tables don't work, GPU cracking doesn't work, you take it out of both of those spaces. But if someone exposes the private key and that gets stolen, the whole system is broken and you go back to just a hash in terms of mathematical computation. So what's more important than key management here is cryptographic isolation. Build a separate web service that takes the passwords and salt and spits out a hash. I don't care if you hard code the key in that application. That's better than if you have rigorous key management and it's integrated into the web application. This is an area of crypto that very few people talk about that's more important than key management. Again, cryptographic isolation when you can do it. So HMAC, the benefit of an HMAC is it's just the speed of a hash. Super, super fast. If that key is protected like I'm suggesting, it's also highly secure and won't be cracked before the sun stops working if the key is long enough. Second, if you don't have that level of rigorous need, I'm going to recommend you use one of these adaptive hashes, scrypt or PBKDF2. If you're building a system that requires good enterprise support, these slides are all open source on slideshare.com, so I'll give you the URL at the end. If you want to take a picture, that's okay though. Okay, I'm ready. Go ahead. Can someone grab her camera? Come on up. Real quick, we got 20 seconds. Grab her camera. 20 seconds.
Oh, okay, sure. All right.
I hope. So back to it. So PBKDF2, this is the better algorithm choice for password storage. When you want to deal with FIPS compliance and wide enterprise support, it's a widely supported algorithm. OSX uses it for password storage. Great choice. If you have a lower number of users and want deeper security, you have scrypt, which takes up like as much RAM as you want during computation and can go as slow as you want. The slower you make these algorithms, the better your protection is, but the slower login takes. So these are good pieces of advice if you don't have rigorous key management in crypto, and it's good for a modest number of users as well. So either of those, and if you're just getting started, just start here, scrypt, bcrypt, or PBKDF2. It's a very reasonable first choice. How strong is this password, by the way? Be honest, don't have to answer out loud, but how many of you in this room will this password fit through your corporate policy? Uppercase, lowercase, number, alphanumeric, and it's over 10 characters in length. So those who do dictionary, you're cheating. You were in this talk before, and you already told about that. You're excused. No. You're exactly right. If you're not doing a dictionary check against your passwords, it's a major problem. This password will fit through quite a few corporate password policies. It is probably the weakest password in existence today, other than 1, 2, 3, 4, 5, 6. So another thing to do is have a list. You can get this from different hacks. Have a list of passwords that are in common usage today and ban those from your system. That will actually provide you more mathematical password security benefit than any password policy I've seen that requires stuff like this. You can get those passwords from different dumps we've seen in history. We've seen Living Social dump a lot of passwords. We've seen RockU get hit pretty badly. Can you cover his ears? Just cover his ears for a second. Thank you. We've seen Sony hit pretty bad with password storage. I still love you, Mark. Password storage as a cryptographic need fades if you do multi-factor. Bruce Schneier says if you're doing multi-factor, your password can go down to like 5 bytes. I don't fully agree with that, but he's mathematically in the right path. If you're not doing multi-factor, considering it, or shifting to it, the era of passwords is dead. Doing rigorous password storage is like putting a motorcycle helmet on and then going down the 115 at 200 miles an hour trying to get to the canyon in 20 minutes. How good's a helmet going to help you at high-speed collision? It does not. Over 30 miles an hour, a motorcycle helmet's no longer useful to protecting you in any way. So I kind of see that password storage in the same area. And for a big company with a lot of consumers, moving to multi-factor is a huge pain. But I'm telling you, Twitter did it. Dropbox has done it. Amazon Web Service. Apple, talk about the pillar of insecurity, but even Apple. Did I say that? Did I just say that? I'm sorry. I love you, Apple. I love you, Apple. Yeah. PayPal offers PayPal has the best multi-factor token I've ever seen. This convinces me we can have multi-factor for dozens of websites. It's a business. It's the size of a credit card with a little multi-factor system in it, and they give those out for free now. Yeah, they charge you for it. Just complain if it. They'll give you one for free. Facebook, Google. We have enough folks. Even Blizzard. Who is the first on this list? I just told you. Who's the first on this list to do multi-factor wide scale to a large number of consumers? For what reason? To protect World of Warcraft. There's a huge amount of fraud in World of Warcraft. This is a $500 million a month economy. That World of Warcraft was the biggest financial win of any game in history and probably will not be beat in our lifetime. Battle.net Authenticator, I have it on my phone as well. And they were getting so much brute force attack fraud that the moment they instituted multi-factor, that almost all went away for users who used it. So in the real world, the benefits were dramatic. Something you got to consider. I'm probably preaching to the choir. I'm running out of time, I think. How much time do we have?
You got over 20 minutes.
Awesome. Forgot password storage. Here's another example of a sub-authentication control we have to master. This fits in the functional requirement category. So I can have QA, normal QA staff and not security staff, test this pretty rigorously to see if it's working without too much education and setup. And I recommend a multi-stage workflow for forgot password that mimics what multi-factor is. This is what like Chase and big banks do today. I think it's a good idea. Now, when you're a bank and you're thinking about email, what does a bank think about trusting your email account? How much does a modern bank trust you and your email account? If you look today, most major banks will use email to communicate with you for almost nothing today. They'll never send your account balance over email. They'll rarely send you authentication information over email. They won't even send you a message. They'll say, you have a message on our website, please log in and check it out. And so because most banks assume that email is fully compromised. This forgot password workflow, the intention of it is to do multi-factor in the case where your email is compromised and still maintain security of the identity. Step number 1, ask the user hits forgot password. Step 1, ask for identity information. Chase will ask for like your social security number and your account number and a list of choices. So 2 pieces of identity information. I now know who that user is. Step 2, optional. I think Wells does it, Chase doesn't, is ask a security question. I've never gotten this right, so I always go to a guide. We have the choosing and using security question cheat sheet. There's no such thing as a great security question. We can at least do good ones. This will talk about that in depth. It's an optional step. Now that we know who the user is, they answered the security question, we now want to send them a token, preferably over a dedicated token. SMS is okay. Some banks still use SMS. And even the token over email is acceptable. It's better than a password. It's not great. The reason being is even if email is compromised, if I'm able to if I'm as an attacker able to steal that token, I still need to be in the session with the identity information and the security questions answered correctly, or that token is no good. Next, we get the token. The user enters the token in the same session that they started the process. We now let them change the password. If you're a Chase customer, I don't work for Chase. I just used it a few days ago and reset my password. Walk through one of those workflows and simulate it in your own high-risk software. It's the way to go. Most consumer sites, how do they do forgot password? They send you a link. And if your email is compromised, so is your whole entire account. That's why no bank worth their weight in government subsidies should ever be doing that, right? Next, a control that's not used enough is re-authentication. Every single website in the planet should force you to re-authenticate when you're trying to change your email address. Why?
Because you could send, like through process scripting or something like that, just send a change of email, and then all of a sudden you send all the password resets to your email address with the same pattern.
Exactly. Most consumer websites use password reset links to forgot password. If I can maliciously change the email address to be mine, I can usually trigger forgot password, get a link, reset the password, and now the whole account's mine. And that's why Amazon and other websites, the moment you change your password, they wipe all your credit card saved data. That's another good control when these serious things happen, like someone's changing their email address or their password. It's not a bad idea. So here we have Amazon, Meetup, Facebook, and Twitter all forcing me to enter my password just to change my email address. This is something I think we should all follow. It's a good idea. And authentication is such a big topic. We have a series of cheat sheets that talk about this. Authentication, password storage, forgot passwords, session management. We're not even covering the whole topic. We're missing a cheat sheet on OAuth is the next thing I think we should be working on. If anybody here has expertise in OAuth, and just to split hairs, yes, OAuth is really access control and not authentication. But if anybody has expertise in OAuth and would like to work on an OAuth cheat sheet, we'll make you famous, and we greatly appreciate your volunteerism. Just drop me a line. I can help you with this, because identity is such a huge topic. We can do a cheat sheet. We can do a top 10 on authentication alone and still not cover the whole topic. I already went through access control. I'm going to jump ahead here. A quick note is content security policy. Gots to keep your eye on this. This is becoming a much more important standard every day. The W3C is finally solidifying on a standard that all browsers will follow. And the main purpose of content security policy is an XSS defeating standard. It's no longer like manual coding. It's now a browser-based standard that's looking really sharp. First of all, you must take all of your JavaScript and put it in separate JavaScript files. Then you can apply policy to tell the browser, look, my JavaScript files are in this one folder only. Ignore any other JavaScript. So if the attacker submits like a blog post with JavaScript in it, that gets rendered in the body of your victim's browser. If that supports content security policy, it won't execute because it's JavaScript that's in the body of the web page, not in a separate JS file. Very effective standard. And something that a lot of people don't talk about when it comes to content security policy that I want you to keep your eye on is script hash and script nonce. So and these are just becoming solidified in the last couple of weeks. The content security policy script hash and script nonce directive lets you set up integrity checks for existing inline static JavaScript. And this is amazing and not talked about enough, because if I have a website with lots of inline JavaScript, I can still use content security policy to lock it down without moving that script to separate JS files. So this is good for legacy remediation. Firewall vendors can start doing this and apply this defense via automation. This is going to be one of the bigger deals in CSP for legacy remediation, I dare say. Next, what am I talking about in this section? And tell me why I should skip this section. What's the only way to stop SQL injection? Any ideas, anyone? Which technique do you need? Which technique, I don't want to give you any hints here, but which technique do you need to master to get SQL injection prevented in your web application? Any guesses? This is the only area of the OWASP top 10 preventive controls where we're directly addressing one granular control. Why? Pardon me?
Over 90% of website use database.
Because it's such an important issue, and it's like if you have this vulnerability in your website, it's the angel of death. I need 2 characters to take out a site or less. I watched one of the top 100 Alexis websites go down because of this attack. They injected a single quote semicolon into an email address. This is the final query. When the database sees it, it ends up just a single quote semicolon attack, ends up running an update statement that wipes out email for the whole database. So we know about this already. You stop the problem with query parameterization. You have a binding and a placeholder. So, placeholder and binding statements. Here's where untrusted data must enter the query. Programmers usually do string building for this. It's a failure. We want to use query parameterization. It pre-compiles the query so your injection attack cannot change the structure of that query. We all should know about this already. I'm going to jump over it fast. If you're new at stopping SQL injection in code, I ask you to please go read the query parameterization cheat sheet. It's 1 page, printable, give it to your developers. It's the only way to completely stop SQL injection, and it's a really simple technique. If you can't stop SQL injection in code, across your whole inventory, then other efforts in application security have very low meaning. So one of the ways I think large organizations should approach application security from maturity phase 1, just get all SQL injection out of code across your whole inventory. This tests your ability to remediate. It tests your ability to understand your inventory. It tests your ability for coders to fix the easiest problem in code.
But Jim, we got a million lines of code, how do we do that?
I'm not saying it's an easy problem. I'm not even saying it's a cheap problem. I'm just saying if you can't, other efforts in application security have low to no meaning. So how do you do it? And very often you got to, especially today, I'm seeing pushback. People don't want to spend this money. They want to spend money on things that help them make money, not things that are just like, stop other things from happening. But you got to get board and C-level visibility. If you have a problem where you have many million-line code bases and a large business, and this is software that your business really depends upon, and you don't have time to fix SQL injection in it, that's a cultural problem. You need board and C-level visibility at that point to make sure they understand how serious it is. That's my advice. Because if your board and C-level staff are not willing to invest and care about this, again, other efforts become minimized. But luckily, and if you were trying to talk to the board about this 5 or 6 years ago, it was a really challenging conversation because we didn't go through the last 5 years of the golden era of hacking. If you go approach your board and C-level folks today, they get it because there's been so many wide-scale events. Those suckers, the C-levels and the board has to sign off on a lot of these things now legally. It's their liability as well. That conversation should be much easier today than it was even just a few years ago. And again, if your board and C-level staff is not willing to invest, at least modestly, in this, get a new job, dude. There's a lot of jobs for security people out there. Give me your resume, I'll help you out. And I mean that seriously. I mean that very seriously. We're security professionals. We need to be able to do our job. And if we're taking a job with a company that's not going to let us at least do the basic due diligence, that's going to hurt us as a professional. I say move on. And I don't say that lightly, and it's a kind of a strong statement.
So when you reach they beat you up, they're not doing your job.
Other thing is, when I make these recommendations, I now start CCing in other executives to make sure that visibility is there. It's got to be politically sensitive about this, but I have seen security guys who've talked about this for years and told the company we have to do these things. The company won't do them, and then they blame him when things go sour. So protect yourself as well. I hate to say that, but we really have to these days. Cross-site scripting, we know about this as well. How am I in time? 4 minutes? 14? Awesome, thanks. 13. Let's talk about cross-site scripting next. I'm not going to go too much into detail about this, but it's an area of risk that is really difficult to stop across a large scale of inventory of applications. Because a lot of people talk about output encoding, but if you really want to stop cross-site scripting, JavaScript-based attacks, this is when the attacker submits evil JavaScript into your website in some way, so other users, victims of that website, run across this evil JavaScript, can cause all kinds of harm. To really stop cross-site scripting, you need a knowledge grid like this, based on the kind of data that's being submitted to your website, based on the context of where that data is used. We're going to need a different defense, from sandboxing to parsing JSON a certain way, to doing DOM XSS defense in JavaScript, to sanitizing and validating untrusted HTML, to certain kinds of strict validation, to only allowing certain kinds of URLs, other kind of validation, to output encoding. So we need all of these techniques to really stop XSS. And very few teams get this really right the first time out. They usually got to be beat up a bit before they get it. But the most fundamental defense, though, is still going to be output encoding. When your browser sees this character, it thinks of it as a tag. When your browser and starts a new tag, it's not data, it's code at that point. It's going to render the HTML rendering engine and start executing, looking at what tag you're starting. But if you drop this sequence of characters into a web page, this is the less than sign and its encoded variant. So this will be a display-only version of the less than sign, and if it's part of an attack, it will neutralize that attack. So this is the heart of XSS defense is output encoding, and there's not enough good output encoding libraries out there. One of my favorite projects at OWASP is the Java encoding project. It was written by one guy who is a PhD level intellect who went and got Gecko and all the different browser rendering engines and studied how they create HTML and built his encoder specific to web standards and how browsers actually render HTML. Outstanding research, the most detailed library I've seen. And here's an example of how it's used. We have different fragments of HTML developers building. They want to drop this untrusted message into the JavaScript lock. So we say encode for JavaScript lock, and we've now neutralized that input to a display-only form specific to JavaScript because we're in JavaScript space. Here we have a button, and we're putting a message in the middle of an alert handler. Now we're not in pure JavaScript space, we're in the middle of a JavaScript attribute, like an event handler. We have a different kind of encoding. Here we're dropping data in the middle of the text area, so we do basic HTML output encoding. Here we're dropping data in an attribute, so we do HTML attribute encoding. There's about 30 or so encoders. Developers can skip lots of these. They can just use this one. It's a little bit less efficient. They can just use that one for this family for HTML. It's a little bit less efficient. The granular APIs are for people building their own template engines that automatically encode if you want to be ultra granular in how you do it. And yep. And these are the different encoding libraries in different languages. Finally, in Ruby on Rails, it's built into the language. In the Reform project, an older OWASP project, we see encoders for legacy like classic ASP. In the ESAPI project, we see a Java encoder, probably one of the more often used encoder in the Java world. I'm more of a fan of the Java encoder project. It's a bit more efficient, but hey, they're both reasonable. And .NET has a built-in anti-XSS library that's actually quite robust. So those are the different encoding libraries that developers need to master to stop cross-site scripting. Another area of XSS is dealing with untrusted HTML. Here's we have a tiny MCE. When you hit submit on a tiny MCE widget, this is a WYSIWYG widget in the web. You can make bold, bullet points, like any other text editor. When you hit submit on that, you have a big chunk of HTML. So I have this big chunk of HTML that's coming from a user that's not trusted. How do I lock this stuff down? Anybody have an idea of how I take a chunk of untrusted HTML and use some kind of security control to make sure there's no JavaScript in here? How do we fix this? Should we, what if you have this HTML and you encode it? What's it going to look like on the page? So think about this. You have this less than sign, and we're going to encode it. What's it going to look like on the page? Ampersand LT semicolon. What does that look like when you render it on the page? It looks like a less than sign. So you're going to, when you take this code and encode it, what are you going to see on the web page? All this code. It won't render, but it will look like this big chunk of code. I don't want this big chunk of code on my web page. I want this pretty stuff with the image and all the bolding and the links. That's the whole purpose of this WYSIWYG. So how can I take untrusted HTML, get it from an untrusted source, secure it in some way, so I can safely render this HTML in other users' browsers? Can we build a regular expression to sanitize HTML? Not with a team of 1 million people, we could not. That's not what regexes are for. We want to use some kind of formal HTML sanitizer. At OWASP, Michael Samuel, the lead application security engineer for Google, dropped Google's Java HTML sanitizer and donated it to OWASP. Awesome. It's made for high performance. It's used at Google for a lot of different other properties. It's made for performance and low RAM utilization, and it's a programmatic HTML sanitizer. In this case here, I'm saying, give me a new policy factory, and I'm defining a rule about allowing links. I'm saying allow the A tag, which starts a link, HTTPS URLs only, allow the href attribute only, no relative links allowed, and build it. Anything that doesn't fit this rule will be stripped out of the content. So that's an example of how to build a policy for untrusted HTML and secure things like tiny MCE. This comes up all the time, and every language has some kind of HTML sanitizer. Java, I just talked about it. Ruby on Rails for 3 and below. You got the Loofah project for 4 and above. You have the HTML class built in. For .NET, They have a built-in HTML sanitizer, the GetSafeHTML and GetSafeHTML fragment API. These are both way too restrictive and not usable with tiny MCE and similar widgets. So I recommend the HTML Agility Pack, which gives you a configurable sanitizer. Now, Microsoft has all these tools internally that are much more mature. They're threatening to dump it on us in the next version of .NET. We'll see. PHP, we have the HTML Laud project, Python, the Bleach project, and there's even some pure JavaScript sanitizers if you're doing like Node.js or if you're doing like really heavy JavaScript client-based programming. So we have these libraries available, you just got to use them. File upload security is another specialized area of input validation that people get wrong a lot. It's incredibly challenging, usually requires some interaction with the OS, a little more interaction with the OS that I'm comfortable with because it's file I/O. I'm going to skip this topic because we're running out of time, but this is another area that requires a very sophisticated defense to really get right. And this is out of place, but let me go here anyways. Comments from the field. So Jim said the point of treating all client-side data as untrusted is very important. And we can tie this back to the whole security design of tiers and boundaries in design and architecture. The point he's making is that you don't need to validate at every single tier, where I academically feel we should. But Jim's, and that's the second bullet point. Ideally, I'd like to consider all tiers to be untrusted and build controls at all layers, but this is just not practical or even possible for some very large systems, which is why having zones of trust and depending on certain defenses upstream, as much as I may not like it academically, it's required in complicated systems. Mr. Bird is, of course, right here. So I'm going to finish up with encryption. So what do you think of the certificate authority system that drives the heart of SSL's accountability? It's bunk. It needs to go away. And I've said this at conferences where I've had like product managers of certificate authorities in the room like publicly almost throw things at me, but this is the reality. HTTPS gives us 3 benefits: confidentiality, integrity, and authenticity. Integrity, no one can modify the data stream. Confidentiality, no one can look at the data stream. And authenticity, if you're getting data from bankofamerica.com, you know for sure that source is authentic. And which organization is built around that authenticity piece? Which system tells us that we know for sure that server is the right server? It's a CA system. So look at TrustWave. I'm not attacking them. I actually think the more time goes on, I think they did a good thing. So not what they did, but how they reacted to it. TrustWave got caught taking their root, they're a CA, so they had their root certificate, and they basically sold it in a product, in a data protection product. So now, as a customer, I have basically my own certificate authority, private certificate in an HSM. That's ultimate power. I can now see you making an SSL connection to Google, and I'll wait there. I'll make a new Google cert on the fly. It's not a real Google cert, but it's one that I just made on the fly that has Google in it. I'll sign it with my private CA certificate that I just bought for a couple $1 million. I'll sign it and give it to you. Now that's not the right certificate for Google, but it's signed by a real authority, so the browser doesn't complain. That's one way you can do CA-based man in the middle. And this is a prolific problem. We've seen it on multiple situations. It's at the government level as well, and I think it's a big problem. And so we can fix this. And I'm going to talk about this from the most important to the least important. So the most important thing I think we want to support is certificate creation transparency. Google is suggesting that every CA must support a public text file that lists all certificates they create, and then all the browsers can use this to make sure that fraudulent certificates are not created, or we can at least detect when some CA creates fraudulent certificates. So that's one suggestion that Google likes, but none of the CAs like it. They're like, we don't want to reveal, we don't want to reveal who our customers are, whatever. We can figure that out already. So, I mean, technically, we can figure that out already by looking at various things. So that's one idea. I think it's the most important idea. The next one, as a programmer, you should master is certificate pinning. This is a key continuity scheme. You're basically taking your certificate of your SSL certificate, the public part of it, and hard coding it in the client. You hard code it in the mobile browser, you hard code it in the mobile app, you hard code it in your thick client, and pretty soon you'll be able to hard code it in the browser as well. Chrome already does this for like Twitter and Google and some of Google's friends. And what this does is, if I get in my browser a legally signed certificate that's signed by a CA, but it doesn't match the hard-coded version, I reject that connection because someone just gave me a properly signed certificate that's fraudulent, and there's no way to detect that other than certificate pinning. There's a cheat sheet written by Jeff Walton from OpenSSL who wrote this in great detail, a critical read if you really need much more rigorous SSL defense. A place to use this is if I'm doing like mobile banking, and I'm going to pin a cert in that mobile app without even thinking about it, and have to update the app every time my cert changes every couple of years. And now when someone man-the-middles me, even the sophisticated one I just mentioned, I'll detect it and can handle it. So we have browser certificate pruning. This is Zane Lackey over at Etsy. He found out that you can strip out about 95% of all CA certs from your browser without affecting usability at all. Most CA certs in the browser, which is used to verify authenticity, are unnecessary. So that's a really interesting read if you grab the slide deck. Strict transport security, the last one. This is a standard that your server can give to the browser to force it to only go SSL to your server from that point on for a certain amount of seconds. So this can harm privacy, but I make sure that wildcard certs must include subdomains. More on that later. So last note on cryptographic storage. We commonly use AES. It's probably the default algorithm for cryptographic storage today. We want to avoid ECB mode. We want to prefer glossy encounter mode and the benefits of forward security. We also want to these days, if you need to do wide support, you're probably doing AES CBC mode. This is what Keyzar still uses. And if you're in CBC mode, you have to deal with initialization vectors. It should be unique IV per message with the proper padding, proper key storage, and cryptographic isolation. Don't forget confidentiality to HMAC your ciphertext for integrity. Derive your integrity and confidentiality keys from the same master key with labeling to split that. And don't forget to generate a master key from a good random source. And good luck with that. So.